All right, folks. Just stand by. We're going to get started in just 1 minute. Let's see. Cool. All right, let's see. Oops. Trying to find where we left off here. Perhaps it was in the other one. Probably was in this other cohort. Here we go. So, oh, looks like we got a question already. Good. Let me copy in this link. So this question is regarding the KW-args section in challenge 3. I can supply code and what I think we should pursue to remedy this situation. Yeah, sure. Please provide any code you want me to take a look at, and we'll go through it. Okay. So this is for challenge 3 in KW-args. Excuse me. And I'll put in the code provided. Oops. We got Slack trying to do every fancy possible thing. I just want to copy the code that's in there. Okay. I feel like this used to be easy. Okay, cool. Cool. So here's the code. Just check out, make sure we don't have any weird characters in this. Okay. Let's give this a little run and see what's going on. Okay, cool. We have valid code, so that's a good place to proceed from. All right, let's see what this function is supposed to do. So write a function called sep and sort, which takes any number of unnamed parameters. The function will take any number of integers and floating point numbers. It should go through all of the items that were passed, separate them by type, and then sort each collection. The return value should be a list of lists, where the first list is for integers and the second list is for floating point numbers. Okay. If no values of a specified type are passed, do not return an empty list. For that type, remove it all together. Okay, so we're only gonna classify values that are in both. Okay. No values for a specific type. Okay. So I'm seeing this first example here, which shows me that we expect a list with only one list in it. So we don't want to have an empty list if there are no float values passed. Right. So in this example, so this is always kind of a key thing. I tend to get more use when I'm trying to go through a problem statement and trying to understand it. I look to see if there are any examples or tests. We generally provide these in Learn. There's some cases where I think we don't, sort of strategically, to kind of give you the opportunity to do that yourself. But in general, we will provide examples. In Code Wars as well, you'll have tests and also examples in the problem description as well. So in this case, this tells me something interesting about the expected behavior here, which is that we, like I said, we are passing in only integers here. So since we don't have any floats, this list output only contains one nested list and it's only integers, rather than having like an empty float list like this, right? So we need to handle that. It's kind of funny because I would consider this more an edge case than anything. But we could do, presumably if we do like 0 point, and I don't know, we'll just do that. Presumably we should have these in the list as well. Okay, and then for this, there's quite a bit here, so I'm just going to leave that one there for now, and we'll do one that's just ints, one that's just floats, and then one that is ints and floats. And for this one, we expect ints first, then floats. Do that there. Okay, cool. So let's see what we get. Okay, cool. So it looks like this last one -5, 1, and 2, and then -3.5. See, I actually didn't. I forgot to order these in the proper way, but these are ordered correctly. We can see these are actually sorted correctly, so we'll do this. But the problem here is that we have, for the cases where we don't have integers or we don't have float, where it's only one or the other, we expect only one list, and in the output we have an empty list. So that appears to be the issue. So I think, I mean, we could probably rewrite this logic to like prevent that in some way, and let's take a look at that. But just to start off with, let's just do something boneheaded, just a nice simple solution. We'll just say if len of float nums equals 0, then yeah, we'll just do this. We'll need 3 returns for this. We'll only do int nums. I'll copy this. I'll say elif len int nums equals 0. We'll only do float nums, else we'll do both. Cool. And that'll do it. Let's see if that is going to accept it. Oh, looks like it didn't like it. Okay, let's see what happened. Interesting. Very interesting. Ah, okay. So it looks like if we get nothing passed, this is an edge case that I didn't anticipate. If we get nothing passed, we should get one empty list, it looks like. So I'm going to actually handle that case first. We'll do an elif here, elif there, and we'll say if len float nums equals 0 and len int nums equals 0. So we're going to check them both in one condition. Then we're just going to return an empty list. And it just occurs to me, we can do this actually right up front. We can just say if len args equals 0, return empty list, and that'll actually do the same thing. So I can go back to what I had here, and that should do it. Okay, let's just see if we can force this thing to pass just with raw brute force. Cool. All right. Well, let's look at their solution later. Yeah, let's see if we can clean this up a little bit. So one thing that I can think of a way to clean this up a little bit is if we just have like an output list. Let's just do like out list equals list. We're just gonna do this. Oh man, there we go. Yay, symmetry. Okay. And then I'm gonna say if float num, we're gonna do not equals 0 for both of these. not equals 0, then we're going to we'll just append these to outlist. Outlist dot append. Okay, so now this reads if float num list equals not equals 0, then we're going to append. Oops, and actually we want to swap these. So we'll append float num, and if len of int num list not equals 0, then we'll append int num to outlist. And then in this case, pretty straightforward. We'll just return outlist. Let's try that, see if we get the same output. Uh-oh. Am I getting the right output there? Oh yeah, right. I caught this and then I forgot about it because I wanted to give an example of this, right? I got myself with my own trick. So if you look at this output change down here, let's see. We expect empty list, then ints only, then floats only, then both. What we get is empty list, ints only, floats only, and then floats only again. It's because I'm checking floats first, and if this first condition is true, i.e. if the length of float num list is not equal to 0, then we're going to append it into the sorted version of it into the output list. And the length of int num's list might not be equal to 0 as well. But since this is an if-else, as soon as one of these conditions is true, it's not even going to bother checking the other one. So we can do this, and this will allow both to be checked, and that'll be a bit of an improvement. So let's submit this and see if that's going to work. Actually, I kind of want to save that solution. Cool. Meh. Okay, let's see what happens. Okay, so we have, this is giving us an assertion error, and it's saying that these two lists are different. Oh, right. So I'm doing floats first and then ints. It actually wants me to do it in the other way. It wants me to do ints first, then floats. So we'll just swap the order in which those get appended. That should do it. Okay, that should do it. Or that did it, I mean. So we'll just copy this. Paste that in, tab this back. Some extra space in there. Let's just clean that up a little bit. Okay. Cool. Okay. Yeah, let's come back to that again. So now I'm thinking, Now I'm thinking, let's see. We got a follow-up question to this. So first list contains 2 additional, oh, this is the error that you were getting. Yeah. So just to give some context to that error, here I'll paste this in for the benefit of anybody else watching. Okay. Slack is still being a baby. Okay, so the error that the asker was talking about looks like this. And this is just saying that it's expecting there to be an empty list, but it's finding these a list with 2 empty lists in it, right? And hopefully it's clear like how I fix that particular problem. And then could we copy and append list and use not equal? Oh yeah. Okay. I think that's what we were doing. Okay, cool. I'm glad that that's making more sense. Good. Okay. Great. So I'm thinking we could even improve this, refine this solution even more. I kind of think we could get a one-liner out of this. I think I want to try. So this might turn into a hairy mess, in which case I'm probably going to just back out. But let's just give this a shot. So I think what we can do, this is super weird, but I think we can do a list with 2 comprehensions inside of it. So I'm going to just try this here. Return list with 2 comprehensions. And the first one will be for ints and the second one will be for floats. So we'll say n for n in so many n's. That's hard to say. We'll say yeah, let's call this I for int, right? I for I in args if type I equals int. Yeah, and then we can do the same thing here if type I equals float. Float, and then just cause, let's just call this f because it's a float. Cool. I'm just going to chance it. Oh, I deleted my comprehension. Oh, that's good. That's fine. And we'll just give this a little bit of breathing room. Okay, that's one problem. I deleted the opening square for that. Okay. Let's just try that, see if that works. Right. We got to sort these. And of course I have the same problem that we had initially. Sorted. So what I want to do, I think I do have to, I think this won't quite be a one-liner, but I can get these sublists in one line. So we'll do int list equals this, and then we'll do float list equals this. And then we'll say, we'll just do something similar. We'll say return. I want to see if I can get this in a ternary. But I don't want 3 conditions. I think just from here we can just do something simple like this. some basic, straightforward condition checking. And then we'll have outlist here. So that's a bit cleaner at least. So a quite straightforward solution. Quite nice to read, actually, I think. Okay, doesn't want to do that. Let's just see if it works, though. Int nums. Okay, we got to do int list. There we go. Try that. Float nums. Right. Forgot that. Oh. Try that again. That looks like it works. Cool. So here's a third solution. Do this one at the top. Definitely not a one-liner, but you know, we probably could pare this down to one line, but it would be a really messy, intense line, and I think this just kind of speaks for itself. So yeah, cool. So the original question asker is saying, it just occurred to me that I was trying to find a way to remove the inty list with conditions. Oh. But looking at your solution, it's clear. It's clear and simple. Clearer and simpler. Cleaner way of doing this to just not return it. Yeah. So I think what you're saying is like you add in the list and you were looking for like a way to like check conditions to see if you would need to remove it later. This is actually a pattern that I've noticed for a while. Typically, it is easier to create additive solutions than it is subtractive solutions. It's generally pretty straightforward to think about when should I add this in. If you can prioritize doing things that way over thinking, okay, now this is in there, how do I remove it? Like, once something is part of a collection, I mean, you can remove it, you can manipulate collections in Python, but it can cause other problems, and I think it's just sort of one of those like easier to think about positives than negatives sort of thing. It's paradigmatically easier to add things in. So yeah, okay, cool. Good. All right. Well, if you have any follow-ups to this, please put them in chat. But we do have another person asking a question, so I think we can move on to the next one. Sorry to keep you waiting. But okay, we got another tuples question. Good. I love tuples. They're like the underdog list. I kind of like using them. They're an easily misunderstood data type. Excuse me there. Okay, tuples are immutable. So it looks like, let's see, I'm stuck on tuples/tuples are immutable challenge 3. Tuples and creating tuples. Cool. To the original asker of the tuples question. Oh yeah, they're saying thanks for the args question. I was stuck on it too. I like the comprehension approach as well. Cool. Good to hear that that was helpful for you as well. Thanks for saying that. So, to the person who asked the question about the tuples, if you have any code or any specific questions that you want me to examine, go ahead and pop those in too. If not, that's fine. But cool. Oh, no worries. No, you don't have to provide code. You're stuck on how to think about it. Okay, great. That'll help me. We'll talk about how to think about it. So let's look at this. Ooh, is this 2-space indented? Oh no, it's 2-space indented. Why do we have this code in Learn? Okay, that's better. Okay, I gotta go in and fix that. Boop. Okay. Good. So complete a function called insert at index 2, takes a tuple called tup, and takes an int called x. The function should return a tuple where x is in the tuple at index 2. Note you can assume, let's do this, note, you can assume the tuple will contain at least 3 elements. Okay, well, that makes it easy. So let's make some 3 or more element tuples. So let's just call this my tup. We'll make some test data first. My tup is going to equal 3, 5, 1, and okay. So we'll have 3 tests for this. Okay. We'll do print. My tup and let's just do this. So that'll make it easy. Give ourselves some space. Actually, is it? There we go. And then we'll say for each of these we expect tuple of 3, 5, hello, 8, yeah, 5. Whew, okay. Okay, so we have some test data, we have our invocations of our function, and we have an expectation of what we want this function to produce given its inputs that we're passing it. All right, let's actually write the function. So let's say, oops, def, and this will be called tup and x, I think was what it wanted. It takes a tuple called tup and an int called x. And we're going to return new tup, I don't know. Yeah. So actually we can, I think what occurs to me is to do this in one line. We'll do tup, we'll return tup, and we'll slice tup. We'll stop at 2. So I'm going to test this, and I'm just going to make sure that in all of these cases I see 3 and 5. Okay, good. That's what I see. And then we'll say I'll say plus tup with x in it. So I should see 3, 5, and hello. Uh-oh. Oh, right. I forgot. When you do a single item, a tuple with a single item in it, you still have to put the comma behind it, because this just looks like parentheses like in math to Python. If you put the comma in it, then it knows it's a tuple, and it's a little bit funky. It's like one of the few times where Python syntax kind of feels a little clunky. But I would expect that. I would expect some clunky syntax in any language. Python certainly excels at being not clunky in almost every regard and beats, I think, every other language that I've worked in. So I'll let it slide with this one. But yeah, that's something just funny you got to remember if you're doing a single item tuple. Obviously, I forgot this time. Then you want to just do that. Cool. All right, so we've got up to the spot. So I think what I want to do now is I now want to start at this is interesting. Tup. Now I want to get a slice that's going to give me the latter half, if there is one, right? So I want to start at, let's just see what happens if I start at 2. Oops, I forgot to concatenate it. I will concatenate that. Okay. So this is pretty close. If I do 3, I think I'm going to get an index out of range, though, for the first one. Oh, no, I don't. That's totally wild. Good. Well, I'm not going to argue with it. It works. So this is a good example. I want you to take note about how I solved this problem. I want you to also take note that I don't need to like know everything about Python. You know, like I'm kind of discovering the solution as I go, which is normal. It's how you know. I want you to take away from this that you don't have to have everything about Python memorized. The valuable skill here is just experimenting, right? I was like, well, if I give it 3, I'm pretty sure I'm going to get an index out of range error, but I didn't. I didn't actually get an index out of range error. I'm not sure why. I want to test that in a second here, but I want to submit this and see if it works first. But this is one of those things. Like, just I see a lot of people like not running their code because they've already determined it's not going to work. And a lot of times I know what they're they're thinking and what they're intending to do, and I'm asking, just try it out, and if you try it out, a lot of times it works. So you don't know for sure if it's going to work until you try it out. So try it out. We'll just do this. All right. I'm going to eat those words in a moment here. I don't know if it's going to pass the tests. We'll see. It does not. All right. Interesting. So let's see here. Where did I go wrong? Oh, it does want that inserted. So it doesn't just want it overwritten. I replaced it. It wants it inserted. I got it. So I do want to do index 2 here then, I think. Yeah, okay. So we'll just adjust that. Good, okay. So that worked. So we're, just hope to show you it's like approximating your way towards the solution. And let's just see. So yeah, it looks like the example solution is exactly the same as my solution here. Just 2 slices with a single tuple in the middle, like that. I thought I had a different notion here. What was I gonna do? There's something else I wanted to show, but oh no, that's what it was. I want to see why I can print. Why I can ask for a slice that's beyond its range. Because if I do 3, let's just use this first case, right? So I have a tuple with 3 elements in it. That gives me indices 0, 1, and 2. So if I ask for tup sub 3, if I index at tup sub 3, I'll just print this out here. Because this is me like trying to discover why that code that I thought was going to give me an error didn't give me an error, right? So if I say tup sub 3 with an index, it's going to say index out of range. Okay, this is what I expect. But perhaps it's different with a slice. Appears to be different with a slice. But I wonder how far I can go. Maybe I can just go one more with a slice, or am I just not going to get an index out of range? Am I not going to get an index out of range with a tuple? Wow. Okay. That's extremely fascinating. I wonder if this were a list, what would happen? Interesting. That is not behavior I was anticipating. Let's go to something like this. Okay. And then let's go to steps of something beyond its current range. Okay. Well, you learn something new every day, I guess. Okay, cool. So, evidently, slices are safe against getting index out of range errors, which I guess it kind of makes sense. But I'm wary of that. I'm like sort of in disbelief. I was sure that was not the case, but there you have it. Cool. Oh my gosh. Did I solved the wrong problem. I'm sorry. Okay. Let's solve the right problem this time. Well, that one was fun. Gosh. What was wrong with me today? Write a function called tuple creating tuple, blah, blah. Looks like, looks like I solved this one. I didn't see the solution. We'll just pretend that it's not there for now. Write a function called tuple creating tuple. This function takes 3 arguments called name tup, age tup, and job tup. The 3 tuples are in parallel since they contain the same number of items. Oh, okay. I think I solved this one the other day on stream, perhaps. Maybe last week. Each item at a given index corresponds to the other items at the same index. Okay, that's what parallel means. Index 0 across all 3 items. Yeah, that's the same. Just giving an example of what parallel means. Index 1 holds the name. Index 2 holds the job. Okay. This function should return a single tuple where all of the values at each given index are tuples of data for the same person. Okay, cool. So let's just get some test data, and we'll just call this my tup, and we'll say what is it? Name, age, job. Okay. Name, oops, age, job. Okay. Name, age, job. And we'll have tuples. So we'll do Clark, 57. It's not my real age. Okay. And we'll say my job is stand up rocket scientist. Rocket human. Okay. Cool. And then we'll do another one. We'll say Joanne is 31. Job is author. And let's do another one. Pokey is 2. Job is cute dog. That's the dog that shows up on stream sometimes. Cool. Okay, so we have our test data. What's the name of this? It took me so long to do that. What's the name of this function? Tuple creating tuple. Okay. Print tuple creating tuple takes in I'll just do this. Okay. Yeah, that'll be fine. And then I think I'm not going to write the example for this because it's kind of obvious and it's just a little bit more typing than I want to do for this question. Cool, but since it's easy to infer what the output should be, we can kind of align it and like make it a little easier to read. Cool. So actually, let's just do this. We'll copy this and we'll say def that, and I'm just going to delete the my's in front of it. There we go. And we'll say return let's just say out equals tuple. We'll return out. And we'll say for name. Now there's a few ways we could do this. I think I want to kind of just start with simple tools and move our way into like more specific tools for this. Let's just do for I in range, and we'll go through. Now range gives us, range is often useful for getting an index. Not only useful for that, but often useful for that. So if I ask for the len, and we know these tuples are all of the same length, so if I say len of, and then just literally any of these tuples, and it could be name tup, age tup, or job tup, yeah, it doesn't matter. Then we're going to get I we're going to get a number that represents the index for all three of them. So let's just print I, just prove that real quick. This is 0, 1, 2, and then our empty tuple. Good. Okay. So we can do name equals yeah, I'm going to do this top, and we'll do age, and we'll do job, and we'll say name, age, job equals name tup, age tup, and okay, good. Forgot to do this. Sub I, and then we will out. What does this return? The function should return a single tuple. Okay, so out should be a tuple. I wasn't sure if it should be a list. And we'll say out plus equals a tuple with a tuple inside of it. Okay, so that outer tuple, we got to put the comma in, since the inner one is going to be, a single element, right? And then we'll say name, age, job. Okay. We'll just give this a little bit of space in here. Good. And we'll return out. Let's see what happens. Clark 57, Stand Up Rocket Human, Joanne 31 is an author, Pokey 2 is a cute dog. Cool, that appears to be the correct output. I imagine my solution, we're going to pretend like it's not there, is going to be similar. Don't look at the other solution. Not allowed to look at it yet. Okay, cool. I think I remember how I solved it, what the other solution was. Cool, this works. The other solution, in addition to using range, we could use another function called zip, Z-I-P. Zip is going to take in name tup, age tup, and job tup, and this just makes it so that we don't have to do all this name, age, job thing here. And actually, let's just crack this open and delete all that, move all that up there, give it some commas, give the old comma treatment. Let's see if we can just do that. Is that going to work? Okay. Oh no. Change documents. Too many hotkeys at once. Okay. Okay, there we go. So for name, age, job in zip, name tup, age tup, and job tup. Okay. So what this does, hopefully it's obvious, but I'll explain it anyways. Some of you may be familiar with enumerate. This isn't, I'm not going to use enumerate here, but let's just give an example of enumerate just to give us some context. Enumerate which will give you the element and the index, IDX and name, right? So, well, I I just gave that example and deleted it. Zip does something similar, right? It allows us to name multiple identifiers from multiple different collections. So we can zip together, like a zipper, multiple different lists or multiple different tuples. I think you can zip together a list and a tuple. I don't think they have to be the same. And anything that Python would consider an iterator or a generator, or a collection or whatever sequence, can be zipped together with zip. And you can see we have 3 items in here, but we could have as many as we need. So it's not limited to 3. You could have 2, you could have 10, or whatever. I don't know. I don't think I've ever used more than 3, but not to say that you wouldn't or couldn't. Let's just try that out. Looks like we get the same answer, and I'm going to copy this. I believe I did that for this answer. Let's just see real quick. Yeah, name, age, job in zip, name, tup, age, tup, and job tup. Yeah. So this is, I believe, exactly the same. Oh yeah. Interesting that I remember this actually now. I did this with a list before, just to give an example that it could be done with a list and then cast the list as a tuple. I think the person asking me was trying to do it that way, so I did it that way for them. Let's just make sure that solution works. And it does. Good. All right. Cool. sorry, I went off the rails and solved that that question too at first. Oh, good. I'm glad it was helpful. Thank you. Top list. I'm just looking at catching up on things. Okay, good luck out there. Great. If anybody else has any questions, feel free to pop them in to the chat. Otherwise, I think I'm just gonna jump in. That's the question. Where should I start today? Kind of. KWArgs. I do want to see if I can get this in one line, but that's for another time. That's not important. Let's just jump into manipulating lists. If you all actually give me just 1 minute, I'm just going to refill my water and be right back. All right, cool. Thank you. Immutability and modifying. All right, this is a topic that we've covered several times recently, and it keeps coming up, which is good because it's a weird one. So quick recap on this. Last time we covered this in Learn material, we talked about what it meant for a type to be mutable. So what it means for a type to be mutable is that the data type itself it's an object in your computer's memory, and that object can change, right? So let's say we have a list, and let's just pretend like this is just a like let's say we have a bunch of registries in your RAM, right? These are all your RAM registries, whatever. The way your data is laid out in your memory, right, is you have a byte code to denote the beginning of a list, and then you'll have your data, and then more data, and then more data, right? Okay, so imagine that these are all just registers in your memory that each hold a byte or several bytes of probably several bytes of data. And they all comprise this list, right? If I can modify this in memory by like adding to it or subtracting from it, then that type is considered mutable. If I can only modify it by like either creating it in its fully formed form, then, or just deleting it if it's already created, then we would consider that type immutable. Obviously, like you can create and delete something, but you can't always modify something. So a type is not always modifiable, right? So that's what we mean by mutable. So what's this look like in practice? Well, let's look at a mutable type, which is lists. So let's print, I'm going to get the directory, dir, of lists. We could actually just put in an empty list here, or any list. So we'll print out the directory for lists, and we'll just look. Some of you may have seen me do this before. I'm not going to go through all of these, not in depth, but we'll just take a look at each of them really quick. So some of these methods for lists cause a change in the value of the list, right? Append, for example, if you know one list method, it's probably append. Append adds an item to the list, right? So if I have my list equals an empty list, and I print it out, my list, and then my list dot append hello, and then print out that after I append to it. We'll just run that real quick. You can see we get an empty list. I'm still printing out dir. Let me actually do that. We can get an empty list, and then we get a list with hello in it. So you can see if I compared the values of these, they would not be equal. But if I get the ID of these, if the ID is the same, then we know it's the same list, right? And we can look at these numbers without reading them or examining them too thoroughly, we can actually see that they're the same number. So that tells me in my program, it regards both of these lists as the same object in memory. This is the same object in memory. So rather than pointing to a different object that's like been modified, it points to the same object that's been modified, right? Okay. So this shows us that lists are mutable. This shows us that append makes a mutation to the list. And this is what I mean. This is the kind of thing that I mean. It changes the value of the list. Clear takes a list with stuff in it and makes it empty, right? It clears it. Copy doesn't really mutate the list, but if lists didn't have mutable methods, copy wouldn't be necessary. You wouldn't need to copy something that can't change, right? Why would you need a copy of something that wasn't going to change, right? Maybe you were going to delete the original, but why would you make a copy of something just to delete it later too? You know, that doesn't really make sense either. So copy is not useful outside of the context of mutation, right? If something has the ability to be altered, you may want to access it again after you alter it in its original form. Therefore, copy is useful. So, but it doesn't really cause what we would call a mutation to the list. It just copies it, returns a copy of it with a different ID. Count. Count is not mutable. It doesn't cause a mutation in the list. Extend is somewhat like append. It extends one list with another list. So you can say list.extend some other list, and then you get the original list that you call it on modified by having all the elements of the input list. Index is not mutable. Insert is like an append, kind of. But rather than putting it on the end, it allows you to put it anywhere in the list. So insert takes an element to be placed in the list and an index in which to insert that element. Pop takes an index in the list and removes the item at that index and returns it. Remove removes a specific item that you specify. Reverse and sort change the list into its reversed or sorted form, respectively. So of all of these, let's just do this. We have append, clear. I'm going to say copy is just, we'll just consider copy to be mutable. Extend, insert, pop, remove, reverse, sort. Okay, so of all of these, the only two that are not mutable are count and index, right? So that shows us that lists have a number of mutable methods that will actually cause a change in the list. Yeah, we'll just comment those out. Okay. If you have more questions on this, by the way, feel free to just DM me, and we will go from there. Excuse me, just briefly have to attend to this. Okay. Good. Let's look at the challenges. So write a function called verify IDs. This function takes in two lists as arguments and will return a Boolean of whether those two lists have the same ID. Obviously, I already have code for this one. Let's just examine this a little bit. We can sort of capture an understanding of this with the tests. So we have verify IDs. Let's just copy this, and we'll print verify IDs. We'll say list of 1, 2, 3, and list of 1, 2, 3. And what this is going to do, it takes in those two lists, and it returns the ID, or it gets the ID of both of the lists and sees if those IDs are equal. Calls or passes both lists to ID. In this case, we can see that the values are equal. Let's write another function that just says verify IDs, and we'll say verify vals. And let's also do verify vals for the same lists here. And let's just do that. Of course, I did not change the code in any meaningful way. I just changed the function name. Okay, cool. Verify vals will just check if the two values are equal. So you can see that the values are equal. That's the second function we call it, checks the values, and the IDs are not equal. So that tells us these are two different lists. These lists live independently of each other in memory. Cool. So let's do another one where I'll just do this. List, call this my list 1 and my list 2. Good. And we'll just say my lists 1 and 2 equals we'll just do a simple list 1, 2, 3. Cool. So this is what we had. These are just abstracted out in what do you call it? Variables. Jeez. Okay, so if I do, we can just try different combinations of this, and I encourage you to try this kind of thing for yourself, right? You can write code like this and help you explore and poke around in Python. So verify IDs, my list 1 and my list 1 are obviously going to have the same ID, right? So what if we set my list 2 equal to my list 1? Would the IDs be the same, and would the values be the same? So this shows us that indeed the IDs are the same. So hopefully this is a good example of this. If I now let's say append my list 2 dot append hello, what's going to happen to the value of my list 1? The value of my list 1 got mutated as well, and that's because we have these two identifiers. My list 1 is an identifier, and my list 2, the actual names are called identifiers. We have two identifiers that point at literally the same object in memory. So they are going to reflect the same value. When one is modified, the other will be modified as well. Excuse me, let me just do that. Okay. So this is, I can't think of a reason for this behavior. I can't think of a reason to justify this behavior, honestly. My list 1 and my list 2, I don't know why you would want two different names for something. Maybe it would make it more like semantically meaningful to think about one thing in two different contexts in some way. But I think the consequence would always be that you would expect the two variables to hold different values, and it would be pretty unintuitive to do this deliberately, and probably better stick to just one. So a better way to do this is if I want to copy my list 1 into my list 2, I can say my list 2 equals my list 1 dot copy, copy, parens, and then I append to my list 2. We'll see what happens to my list 1. My list 1 stays the same. Good. Let's verify the IDs now and the values. Okay, so the IDs are not the same because now they are two different lists, and the values are not the same because they hold different values. So if I, just to be clear about this, we'll print off my list 2 after my list 1, and you can see they have different values. Good. Awesome. So I did this one too. Okay. Write a function called modify third element that takes in two arguments. The first argument is list that is at least length 3, and the second argument is an element that will replace the third position of the list. This function will return the modified list. Be sure to follow best practices taught in previous lessons by not modifying a list that's passed in as parameter. Alright. I guess let's just look at these ones. Let's just look at these examples. So modify third element. Looks like we have two examples here that I've done previously. So this one takes in, well, they're both going to take in a list and an element. And this first one, I'm defining outlist and using this method to copy the list. This is called a full slice. If you look, this is slicing syntax, but what I'm saying, since I'm not specifying a start, it's going to start at 0. Since I'm not specifying an end, it's going to end at the end. And since I'm not specifying a step, it's going to be a step of +1. So this actually does copy the list. This is a de facto copy. It's a full slice. But it gives it back a different list. I could just as easily do list.copy. But either way works. So list outlist equals list full slice, which is a copy, and then we say outlist sub 2, which is the third element, equals element, and then we return our outlist. Alternatively, we can just say outlist up to index 2 plus list of element plus list starting from element 3 forward, and this will give us something similar. This is similar to that tuple problem that I did as well. All right. So write a function called replace at index. Takes in 3 parameters, which are list, IDX, and object, a list, an index value, and an object respectively. The function will replace the element in the list at the index value with the object. You can assume that all inputs will be valid, no index will be beyond da da da. Okay. Let's do this. And let's say equals, and let's all right, my list equals, this should be a list. What should be in the list? We should have at least, well, I guess we can have any number of elements that we want. Cool. And then index will be let's just say index 3, so that's going to be 0, 1, 2, 3, so it should replace this 1. And then we'll say, alright, object is going to be, we'll do hello. A nice, conspicuous, easy to see thing. So, basically I should get the original list, oops. Where 1 is replaced with hello. Cool. Alright, so I think what we can do here is just say return, and we'll do list up to, I think, idx minus 1. No, we'll do idx. We'll do idx, and then we'll say plus, we'll concatenate it with a list of object, and we'll concatenate that with a list slice starting at idx. I think that's going to give it to me what I need here. So I'm expecting, I've got way too much in this list. I don't know why I have so much. Let's just trim off a bunch of this. Good. Okay, so my expectation, let's see, replace that index, right? Replace, okay. So my expectation is 362 hello 3. What I got was 362 hello 1 3. So I still have this 1 in here. So it's going after the correct element, but it's not replacing, it's inserting. So I think, what do I want to do? I want to start at index. So I have to adjust this stopping point where I want it to be at index plus 1, I think. Let's try that. Cool. So I expect 362 hello 3, and I get 362 hello 3. Okay, I think that's going to work. It's only one test, but I don't know, it seems that's what I can think of. So we'll see if it works. Good. Looks like they kind of went with my prior solution above. They're making an output list they call list2, which equals a copy of list, of the original list. They say list2 sub idx equals object, and then just return it. So this is another way to do it. Just copy the list, either do an item assignment, or well, can you do insert? Yeah, I don't think you can. No, you can't do insert. Is there a... Yeah, there isn't a replace method for lists. I always get that confused because there's a replace method for strings, which is kind of weird. So, cool. All right. So that's the last challenge in modifying immutability. Cool. It's getting about time to where I usually like to wrap up stream. So next time we'll be starting in on unpacking lists if we don't have any questions. And of course, as usual, you are free to bring your questions, and I'm happy to ask them or answer them. So yeah, it was a pleasure. Feel free to drop me a line on Slack if you're just watching from YouTube. Come join the Basic Prep channel and in Slack and hit me up. I have a lot of availability currently. My schedule is really open for meeting with students and mentoring meetings. I might take a little bit to get back to you on Slack, but I'll try to get back as soon as I can. Yeah, definitely I'm open to any feedback. If the streaming quality is shaky or anything like that, if the fidelity is bad, let me know. I know the resolution is really low. I've experimented with a number of things to fix that, and I think it's just going to be that way for now. I think we will be able to fix it in the future, but it's just kind of stuck that way at the moment. So apologies for that. But yeah, definitely share with me if you liked it, if you hated it, if you have ideas for improvements. Like, comment, and subscribe as usual, and have a good rest of your day. Bye-bye.